Find cosine of theta and sine of theta given that cosine of 2 theta is equal to 3/4 and theta terminates in quadrant 3. So this time we are given information about the double angle 2 theta. We are asked to find information about theta. We are going to use one of the double angle identities for cosine. I want to use a identity that only has one trig function in it. So the one with cosine or the one with sine, but not the one that has both. So I'm going to choose to work with cosine squared minus 1. So 2 times cosine squared minus 1. That's the double angle for cosine that I'm going to choose to work with. And what we know this time is that cosine of 2 theta is equal to 3/4. So I'm going to set this equal to the right side of that equation. And this time we're going to solve for cosine theta. That's what one of the things we're looking for here is cosine theta. So let's solve. We want to get cosine theta by itself, so we want to add 1 to both sides. When I add 1 here, I really want to give them both the same denominator before I add them. The LCD would, of course, be 4. So 7/4. Then we need to get rid of the 2 that's in front of cosine. So I'm going to multiply both sides by 1/2. So now we have 7/8 is equal to cosine squared theta. The last thing we have to do is to take the square root of both sides. So we have the square root of 7 divided by the square root of 8 is equal to cosine theta. I'm going to rationalize. So I'm going to simplify. That would be the square root of 7 divided by 2 square root of 2. Then I'm going to rationalize. So simplify, separate, simplify, and then rationalize. So I'm going to multiply top and the bottom just by what I need to get rid of the radical in the denominator. So now we have the square root of 14. Square root of 2 times square root of 2 is 2, so I end up with 4. We are told that theta, the angle that we're talking about, lives in quadrant 3. And if theta lives in quadrant 3, then cosine of the angle theta would be negative, and the sine value of the angle theta would also be negative. So we end up getting square root of 14 divided by 4 for our cosine value. Now we want to solve for the sine value. Well, we know the x and we know the r for theta, but we do not know the y. So we'll use the Pythagorean theorem again. X squared plus y squared equals r squared. We're going to fill in the information that we know. X is square root of 14. We don't know y. And r is 4. So square root of 14 squared is 14 plus y squared. 4 squared is 16. Subtract 14 from both sides. Take the square root of both sides. We end up with plus or minus the square root of 2. Since we know that sine is negative, then we know we're using the negative value for y. So it's the y value of square root of 2 divided by the r value, which we said was 4. Once again, here we are told information about the double angle. So we know that cosine of 2 theta is equal to negative 28 divided by 53. And we are also told that theta lives in between 90 degrees and 180 degrees, which we know is quadrant 2. If theta lives in quadrant 2, then what we are asked to find, cosine theta, cosine in quadrant 2 is negative. Sine of theta, so sine in quadrant 2 would be positive. We're going to use one of our double angle identities again. So cosine of 2 theta is equal to, and you can choose to use one of the cosine double angle identities that has only either cosine or sine. This time I'm going to choose the double angle identity that has sine in it. So 1 minus 2 sine squared theta. It does not matter which one of those two that you choose. Just don't choose the one that has the two different trig functions inside. That will be more difficult to solve. So the cosine value that we are given is negative 28 divided by 53. We're going to put that into our equation, and then we're going to solve. We want to get sine theta by itself on one side. So we will need to subtract 1 from both sides. Now if I subtract 1, I want to have a common denominator. So we're going to give these the same denominator. And once we do that, then we can combine the numerators. So that's negative 81 over 53. We need to get rid of the negative 2. We can either divide both sides by negative 2, or we can multiply by the reciprocal. I'm going to choose to multiply both sides by negative 1/2. So multiplying across, negative times a negative, I get a positive 106. So positive 81 divided by 106. And then over here we have sine squared theta. So we still need to take the square root of both sides. Square root of 81 is 9. The square root of 106 is just square root of 106. Let's go ahead and rationalize. So we need to multiply the top and the bottom by the square root of 106. So that would be 9 times the square root of 106 divided by 106. I'm going to choose to use this as the y and the r as we use the function definition to find cosine. So we have x squared plus y squared equals r squared. We know y and we know r. We want to solve for the x value. 9 squared, and then we have square root of 106, and we need to square that. So that's x squared plus 81 is equal to 106. Subtract 81 from both sides, we get x squared is equal to 25. So we get x is equal to plus or minus 5. So now that we know x, we already know that cosine is negative, so we know we're taking the negative value here. So the cosine value will be this x value divided by the r. Once again, we want to rationalize, so I'm going to multiply top and the bottom by the square root of 106, so that's 5 times the square root of 106 divided by 106.